The Climate Prediction Center just placed the central United States under an explicit rapid onset drought watch through the middle of June, the first formal institutional signal that the most active weather configuration of the year is locked in for at least the next 14 days. The Storm Prediction Center has a multi-day severe weather corridor running through Friday. The global forecast system puts the Oklahoma Panhandle at 104 degrees by next Wednesday. Here is what every American needs to understand about the next 2 weeks, and how bad this is actually going to get before the pattern breaks. A continental scale atmospheric configuration has now locked over the United States, and the federal forecast hierarchy has confirmed it. As of yesterday morning, every regional surface outcome across the country was being driven by a single, high-amplitude blocking ridge, the shape meteorologists call an omega block, parked across central North America at the start of meteorological summer. The Storm Prediction Center had 2 simultaneous slight-risk severe weather corridors running, one across the lower Mississippi and Tennessee valleys, and one across the central high plains. The Climate Prediction Center issued an explicit rapid onset drought watch for the central and east-central contiguous United States through the middle of June. The global forecast system placed the Oklahoma Panhandle at 104 degrees Fahrenheit by next Wednesday. The Atlantic hurricane season officially opened with 0 tropical formation, expected during its first 7 days. And in Alaska, 3 concurrent storm warnings produced 50-knot winds and 23-foot seas in the Bering Sea. At the same hour, the lower Matanuska Valley was placed under a red flag warning for fire weather. These are not separate weather stories. Every one of them is a regional face of the same atmospheric configuration, and that configuration is forecast to hold through at least the middle of the month. Most Americans are about to find out what the rest of June looks like. They're going to find out the hard way. The severe weather started before sunrise yesterday. A line of thunderstorms across eastern Kansas around midnight congealed into a mesoscale convective system south of St. Louis through the pre-dawn hours. By 1:30 in the morning, the complex produced a tornado warning over Kansas City. By midday, it had tracked southeastward into western Kentucky and middle Tennessee, weakening through late morning before redeveloping as a new line of thunderstorms during the afternoon near Cape Girardeau and Poplar Bluff. The Storm Prediction Center's narrative for the day called for what it described as rather widespread, strong, and severe storms capable of damaging wind gusts and some hail across Arkansas, Tennessee, Mississippi, and Alabama. 60 to 75 mile-per-hour wind gusts were the operational forecast, with embedded cells potentially producing 75 to 80 mile-per-hour winds. 80 miles per hour is the threshold where damaging wind events take down power lines, snap small trees, and cause widespread roof damage. The line moved through a corridor with approximately 8 to 10 million people in its direct path. And while the Mississippi Valley line was bulldozing south, a separate slight-risk corridor across the central high plains was producing its own severe weather. Scattered thunderstorms developed near Denver in the early afternoon and tracked rapidly east-northeast across the plains. Damaging winds, large hail, and the possibility of an isolated tornado or two were all part of the operational forecast. The day was not the start of a single storm. The day was the start of a multi-day siege. The air mass that fed yesterday's Mississippi Valley line was the kind of air mass forecasters do not see often. The Storm Prediction Center identified afternoon mixed layer convective available potential energy approaching 4,000 joules per kilogram across central Alabama. To put that number in context, mixed layer CAPE values of 1,000 joules per kilogram are considered moderate atmospheric instability. Values of 2,000 are strong. Values of 3,000 are severe, in the environment where supercells routinely form. Values of 4,000 are upper decile readings for the southeast in late spring. They are the kind of value where forecasters reach for specific operational language to communicate that they are now leaning hard in the direction of impactful weather. The National Weather Service Birmingham office used exactly that language in its morning area forecast discussion. The agency favored leaning in the direction of impactful weather, involving damaging wind gusts. That is the hedge meteorologists use when they have high confidence that something significant is going to happen, but lower confidence about exactly how organized the storm complex will be when it arrives. The air mass yesterday afternoon over central Alabama was hot. The morning surface dew points were in the 70s. The surface temperatures climbed into the 90s under partial sunshine. The combination produced the 4,000-joule instability value that drove the Storm Prediction Center's slight risk corridor. That same air mass is still in place over the lower Mississippi Valley today, and it is going to continue to drive severe weather across the corridor through the rest of the week. Today's severe weather risk has shifted northward. The Storm Prediction Center Day 1. Convective outlook places the primary slight risk over central North Dakota. The forecast Bismarck soundings for this afternoon are the operational fingerprint of an environment that supports tornadic supercells. 0 to 6 kilometer bulk wind shear is forecast at 40 to 45 knots. That level of bulk shear is sufficient for supercells to maintain themselves over multi-hour lifespans. 700 to 500 millibar lapse rates are forecast near 8 degrees Celsius per kilometer. 8 degrees per kilometer is steep. The dry adiabatic lapse rate is approximately 9.8 degrees per kilometer, and any value within 1 or 2 degrees of dry adiabatic in the mid-levels of the atmosphere means the environment is conducive to vigorous updraft acceleration. And the 0 to 3 kilometer storm relative helicity is forecast in the 200 to 250 meters squared per second squared range. Storm relative helicity is the quantity that determines how much streamwise rotation a developing supercell can ingest from the wind environment around it. Values above 150 are considered favorable for supercell rotation. Values above 250 are considered favorable for tornadic supercells. Today's Bismarck soundings are sitting in the upper part of the favorable for supercells range and the lower part of the favorable for tornadic supercells range. The National Weather Service. Bismarck office's hazardous weather outlook listed golf ball-sized hail, damaging wind gusts to 60 miles per hour, and possibly an isolated tornado as the hazards for the afternoon and evening. The corridor extends from central North Dakota south through Nebraska and Kansas. The risk is real, and it lands during the dinner hour into the early evening. The single most informative operational data point in yesterday's entire forecast cycle came from the National Weather Service Denver area forecast discussion. The Denver forecaster, in one morning shift, identified surface-based convective available potential energy values of 1,500 to 2,000 joules per kilogram across the central high plains for yesterday afternoon. The same forecaster repeated the same 1,500 to 2,000 joule range for today, for Wednesday, for Thursday, for Friday. 5 consecutive days of forecast severe weather environment written into a single area forecast discussion by the same forecaster in the same operational shift. That is not 5 separate forecasts. That is the convergent forecast signature of a multi-day persistent atmospheric regime. The configuration over the central United States is not breaking down inside the work week. The Central High Plains corridor is going to remain inside a marginal to slight risk window for severe weather through at least Friday. The Weather Prediction Center medium range discussion confirmed the trajectory. The medium range, beginning Thursday, will be active for the central U.S. and the northern tier of the country, where weak mid-level vortices will generate warm temperatures, scattered thunderstorm activity, and potential flash flooding for the eastern half of the country. The forecast guidance from the Weather Prediction Center, the Storm Prediction Center Extended Outlook, the Climate Prediction Center, 6 to 10 day and 8 to 14 day outlooks, and the regional area forecast discussions across 12 National Weather Service offices is convergent on the same conclusion. The configuration is holding through at least the middle of June. The southern flank of the configuration is where the surface impact gets brutal. The same upper-level ridge driving the multi-day severe weather corridor across the plains is also incubating a heat dome over the southern plains that is forecast to compound through the next week and a half. The Global Forecast System Ensemble through next Wednesday, June 10th, places surface temperatures around 104 degrees Fahrenheit at Gage in the Oklahoma Panhandle, 100 degrees at Garden City, Kansas, 102 degrees at Amarillo, Texas, and 98 degrees at Dallas. Those are not outlier forecasts. They are the convergent ensemble guidance across multiple model architectures, and those values are sitting 10 to 14 degrees above climatological normal for the date. The Houston-Galveston area forecast discussion identified heat index values peaking in the 99 to 105 degree range through today. 105 degrees is the operational threshold where the National Weather Service issues heat advisories. The Fort Worth area forecast discussion forecast mid-90s above normal highs through the entire work week. But the heat itself is not the only story. The heat is landing on the depleted soil moisture ground that emerged from the driest January through March in the 131-year continuous instrumental precipitation record in the United States. The Morales 2019 analysis in the Proceedings of the National Academy of Sciences quantified the mechanism. Dry soils amplify surface heat extremes by approximately 30% through removal of the evaporative cooling break. That amplification factor is the operational reason the next Wednesday forecast is 104 degrees at Gage, rather than the 95 to 98 degrees the same upper-level ridge would have produced on wetter ground. The configuration is loaded. The heat is coming. The drought is not breaking. The Climate Prediction Center issued an explicit rapid onset drought watch yesterday for the central and east central contiguous United States, covering the 8 to 14 day forecast window, the period from June 9th through June 15th. Rapid onset drought, sometimes called flash drought, is the operational term the agency uses for drought conditions developing inside a 2 to 3 week window from the convergence of antecedent dryness, anomalous heat, and depleted precipitation. The rapid onset drought product became operational in 2023. The fact that the agency's quantitative guidance has crossed the threshold for issuing the watch across a continental scale corridor is the strongest possible institutional signal that the heat and dry pattern is forecast to compound past the next 2 weeks and into the third week of June. That watch matters because it is institutional confirmation. It is the Climate Prediction Center going on the record that the configuration is going to hold long enough to produce measurable drought intensification on a sub-monthly timescale. The watch joins the Storm Prediction Center's multi-day slight risk corridor, the Weather Prediction Center medium-range discussion's active narrative through next week, and the Regional Area Forecast discussion's multi-day surface CAPE forecasts as the 4 pieces of operational evidence pointing in the same direction. The configuration is real. The forecast is operational. The country is now inside the window where the next 2 weeks decide whether June ends as a manageable severe weather siege, or as the first multi-week continental compounding event of summer 2026. The eastern face of the configuration is the absence of weather. The 7-day quantitative precipitation forecast through next Sunday shows little to no measurable rainfall expected across most of New England, the Mid-Atlantic, the Carolinas, or Virginia. The wet axis is concentrated entirely across the Great Plains and the upper Midwest, where several inches of rainfall are expected through the period. That dry versus wet split is the operational signature of the Omega Block. The ridge over the central United States extends an eastern flank that produces sinking air, clearing skies, suppressed convection, and very little measurable precipitation across the entire East Coast. The New York City area forecast discussion called for daytime highs, Friday and Saturday, approaching or exceeding 90 degrees away from maritime influence, with possible daily record highs Thursday and Friday at Bridgeport, Connecticut, and possible record high overnight lows on Saturday in outlying areas. Record high overnight lows are the operational signature of nights that fail to drop the way they normally drop. The dew point profile prevents the radiative cooling that would otherwise produce normal overnight lows. The Weather Prediction Center medium-range discussion flagged the mid-Atlantic coast as the region of greatest weekend heat risk concern. The exact language was that overnight lows, struggling to drop below 70 degrees, could lead to increased heat risk concerns along the mid-Atlantic coast this weekend. That combination, upper 80s to 90s during the day, overnight lows above 70, is the operational threshold where heat-related illness becomes a public health concern. The Mid-Atlantic weekend is going to be the first major heat event east of the Mississippi this summer, and it is going to land into a corridor that has not seen measurable rain in over a week. Yesterday was also the first day of the Atlantic hurricane season. The National Hurricane Center Atlantic Tropical Weather Outlook issued at 8 in the morning. Eastern Daylight Time was unambiguous. The exact language from forecaster Berg was that tropical cyclone formation is not expected during the next 7 days. The Eastern Pacific Outlook noted a broad area of low pressure southwest of Baja California, with disorganized showers and thunderstorms in a marginally conducive environment, but no formation expected. The Central Pacific had nothing. The longer-range NOAA 2026 Atlantic Hurricane Season Outlook released in May predicts a 55% chance of a below-normal season, a 35% chance of a near-normal season, and only a 10% chance of an above-normal season. The forecast totals are 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes, with 70% confidence. The agency anchored the below-normal forecast to the developing El Niño teleconnection, suppressing Atlantic activity while Atlantic Sea surface temperatures run slightly warmer than normal and trade winds run weaker than average. The competing factors pull the seasonal forecast in opposite directions, but the El Niño suppression is forecast to dominate. The next major institutional revision of the seasonal outlook will be released in early August before the climatological peak of the season, and the viral hype cycle that built up around an early season tropical storm named Arthur, a system that the long-range ensemble members had flagged on the Day 10 outlook a week ago, was formally closed yesterday by the National Hurricane Center's explicit no formation language. The hype was wrong. The forecast was right. On the same morning, the Atlantic Basin opened quiet. The National Aeronautics and Space Administration's Earth Observatory featured Super Typhoon Sinlaku, a developed major tropical cyclone already producing upper atmospheric gravity wave activity visible from satellite, as the morning's Earth Observatory story. The basin asymmetry between the Atlantic opening with zero formation expected and the Western Pacific producing a super typhoon is not coincidental. It is the textbook expected outcome of an El Niño developing year. The El Niño teleconnection produces increased upper tropospheric westerly winds across the tropical Atlantic, which increases vertical wind shear, which suppresses tropical cyclogenesis. The same teleconnection produces reduced upper tropospheric westerly winds across the western Pacific basin, which decreases vertical wind shear there, and which allows developing tropical disturbances to organize vertically. El Niño suppresses Atlantic activity. El Niño enhances western Pacific activity. The basin asymmetry visible on the first day of meteorological summer was the operational expression of the same mechanism the seasonal climatology has been describing for decades. The NOAA Oceanic Niño Index was at plus 0.11 degrees Celsius for the February through April period, having warmed steadily from minus 0.556 months earlier. The agency's El Niño Watch identifies an 82 to 98% probability of onset during the May, June, July season and a 96% probability of persistence into the 2026 and 2027 winter. That El Niño suppression mechanism is the seasonal scale boundary condition operating against the Atlantic basin for the rest of the summer. The Atlantic is going to stay quiet. The continental heat dome over the southern plains is going to have no immediate hurricane-driven moisture source to interrupt it. The other place the configuration is going to be tested over the next several days is the Pacific Northwest. The state of Alaska is producing one of the most operationally informative weather signals in the entire northern hemisphere right now. There are, at this hour, 3 concurrent storm warnings active across the Alaska Peninsula coastal waters, with 50-knot winds and 23-foot seas across the Bering Sea corridor through this evening. There is a flood watch active for Kodiak Island, valid through tomorrow morning. There is a red flag warning for fire weather active in the lower Matanuska Valley around Palmer and Butte, valid through 10 this evening local time, with relative humidity as low as 20 to 30%, southeast winds gusting to 30 miles per hour, and temperatures up to 65 degrees Fahrenheit. The fact that 3 completely different hazard types are operationally active in the same state on the same day is the surface signature of a sharp atmospheric pressure gradient. The offshore low-pressure system that is producing the storm warning winds in the Bering Sea is driving the same pressure gradient that is producing the downsloping warm winds across the Matanuska Valley. The same atmospheric system, 2 opposite surface outcomes, and that low-pressure system is the leading-edge signal of the Pacific Northwest weekend trough. The upper-level vortex producing the Bering Sea storm conditions today is forecast to translate southeastward across the Gulf of Alaska through the rest of the week and arrive in western Washington by Friday into Saturday. The Weather Prediction Center medium-range discussion identifies the Pacific Northwest as the region where renewed precipitation chances will arrive this weekend. The Seattle area forecast discussion identifies a pattern change beginning tomorrow afternoon as an upper-level shortwave trough begins translating into the region. The Pacific Northwest weekend trough is the first major synoptic event in the next 2 weeks that has the potential to begin to disrupt the western flank of the central configuration. The Weather Prediction Center medium-range discussion also flagged a possible split flow scenario in the European and Canadian models, a configuration where part of the trough exits to the east, while another piece of upper-level energy lingers in the western United States, which would keep the western flank weakened and push the central ridge's eastern flank further east toward the mid-Atlantic. That split flow scenario would amplify the mid-Atlantic weekend heat risk. The Pacific Northwest weekend transition is the configuration's boundary condition test. The forecast guidance is convergent on the configuration passing the test and continuing to operate through at least mid-June. The single forecast variable that will determine whether the rest of June fades from memory or joins the climatological list of patterns the literature remembers by name is the breakdown timing of the central ridge. The historical analog distribution for high-amplitude blocking configurations, like the one currently operating over the central United States, is the reference for that question. The 2003 European heat waves blocking high persisted for approximately 20 days. The 2010 Russian heat waves block persisted for approximately 35 days. The 2021 Pacific Northwest heat domes block persisted for approximately 14 days at peak amplitude. The 2022 European heat waves block persisted for approximately 18 days. The mean persistence of these analog configurations is approximately 22 days, with a standard deviation of about 8 days. The forecast horizon for the current configuration is 14 days, one standard deviation below the analog mean. The mean places the breakdown window around June 18th, with a one standard deviation range from June 10th to June 26th. The Climate Prediction Center's Rapid Onset Drought, watched through June 15th, is institutional confirmation that the agency expects the configuration to hold through at least the lower end of the analog range. The Weather Prediction Center medium-range discussion supports persistence through at least the first full week of June. The Storm Prediction Center extended outlook supports persistence through at least the end of the work week. The historical analog distribution and the forecast guidance are both pointing toward the configuration holding through approximately the second week of June and breaking down sometime in the third week. If the ridge breaks down between June 10th and June 12th, the rest of June transitions to a more zonal jet stream regime, the central heat dome loses its anchor, and the country exits the first half of meteorological summer with a serious but inside the historical range continental event. If the ridge holds through June 15th or June 18th, the cumulative heat impact in the southern plains compounds past the forecast horizon. The rapid onset drought materializes across portions of the central United States. The soil moisture feedback amplifies the heat further, and the country exits the third week of June with a multi-week continental event in the upper decile of historical analog severity. If the ridge holds past June 20th, the configuration enters territory typically reserved for the most analogous historical heatwave events. The country is now inside the window where the breakdown decision is the dominant forecast variable for the rest of the month. The forecast for the next 14 days is operational across every layer of the federal forecast hierarchy. The severe weather is going to deliver, the heat is going to deliver, the drought is going to intensify, the Atlantic is going to stay quiet, the Pacific Northwest is going to get rain by the weekend, and the question that decides everything else is when the ridge finally lets go. The country has been given fair warning. The next 14 days will tell us which way June goes. We will be tracking it every day until the configuration breaks. Stay with the forecasts, stay with the alerts, and expect the worst. This is going to be brutal.